Welcome to Daily Dose of Space Channel, where we delve into the awe-inspiring details of our very own star, the Sun. Join us on this cosmic journey as we explore its origin, speed, mass, and various other fascinating aspects. Let's get started! Origin and formation. The Sun, a G-type main sequence star, was formed approximately 4.6 billion years ago as part of a vast molecular cloud composed primarily of hydrogen and helium. Gravitational forces within the cloud caused it to collapse, triggering the birth of our Sun at its core. This process, known as stellar nucleosynthesis, led to the fusion of hydrogen atoms into helium, releasing an enormous amount of energy. Structure. The Sun consists of several layers, each with its distinct characteristics. Core. The core is the central region where nuclear fusion occurs. It has a temperature of about 15 million degrees Celsius and a density more than 150 times that of water. Radiative zone. Surrounding the core, the radiative zone is a dense region where energy generated in the core gradually moves outwards through the absorption and re-emission of photons. Convective zone. Above the radiative zone, the convective zone is a layer where hot plasma rises and cooler plasma sinks, creating convection currents that transport energy to the surface. Photosphere. The photosphere is the visible surface of the Sun that emits the majority of the sunlight we see. It has an average temperature of around 5,500 degrees Celsius. Chromosphere. Above the photosphere lies the chromosphere, a region that emits a reddish glow during solar eclipses. Corona. The outermost layer of the Sun's atmosphere is the corona, a tenuous and extremely hot region that extends millions of kilometers into space. The Sun is an enormous celestial object with the following measurements. Diameter, approximately 1.4 million kilometers, 109 times that of Earth. Circumference, about 4.4 million kilometers. Volume, around 1.41 million cubic kilometers, 1.3 million times that of Earth. Mass, approximately 1.989 times 10 to the power of 30 kilograms, 333,000 times that of Earth. Rotation and speed. The Sun does not rotate uniformly due to differential rotation. At the equator, it completes one rotation in about 24.47 Earth days, while at the poles, it takes roughly 34 Earth days. This differential rotation creates solar activity like sunspots, flares, and prominences. The equatorial regions rotate faster than the polar regions. Energy production. The Sun generates energy through a process called nuclear fusion. In its core, hydrogen nuclei combine to form helium, releasing an enormous amount of energy in the process. This energy is primarily in the form of light and heat. The Sun's core converts around 600 million tons of hydrogen into helium every second. Solar wind and sunspots. The Sun continuously releases a stream of charged particles called the solar wind, which extends throughout the solar system. Sunspots, dark regions on the Sun's surface, are associated with intense magnetic activity. They occur due to disruptions in the Sun's magnetic field and often accompany solar flares and coronal mass ejections. The Sun, our life-giving star, is a magnificent celestial object with a rich history and numerous captivating features. From its origin and massive size to its intense energy production and dynamic solar activity, the Sun continues to astound us with its beauty and power. We hope you enjoyed this exploration of the Sun's fascinating details. Don't forget to subscribe to our channel for more cosmic adventures. Until next time, keep looking up!